Okay, we are already on stream that I start my talk about fuzzing, getting started with fuzzing. What is fuzzing? How many people knows what is fuzzing? Okay, a few of them. Okay, great. Fuzzing is type of automated testing that's continuous manipulate your input. That's important for you that you can easily find bugs, and fuzz testing is usually used and very valuable for finding security exploits and vulnerabilities in general. This is some fuzz test how is implemented in Go. You can see here that we have fuzz test. That's classic interface as testing interface, but with new nuance .f, similar what is B for benchmarks and T for unit test. And we have here function that adding our generated seed corpus into our fuzz target. That's .fuzz functions as every name is fuzz as prefix of your functions, and file is just part of underscore test files, the same as benchmarks unit test. It's the same pattern. And you can see here we as input for fuzz function is testing interface, classic as unit test, and fuzzing arguments that we will iterate on them using, and there is classic function for testing, and we will iterate on corpus and getting some new things from that output. We don't have any results here. You will see after that. What you need to run that fast testing? It's 1.18 Go lang. That was first version, and you need architecture. It's supported. It's only on AMD 64 and ARM 64. If you're using Sparks or something, that you have to wait for others. And we have support only for a few types of arguments. You can see that that's not everything is supported. For example, you can missing, for example, array of strings or structs. That's quite important, but this basic implementation just covered these simple types. But it's way how to go around. There is a tool called FZGen that can help you about structs and complete interfaces using some wrapper around normal call. You can find buggy sequence, including data races, data logs. Rich signatures types are supported in the tool, and I think in future we will see something in Go directly, maybe too. What is important for fast target is that it's fast and deterministic, that the fuzzing engine work efficiently, trying find suitable code coverage, and new files can be easily reproduced, that every testing inputs are stored as files, that if your test failed, you exactly see what was on that input. You can easily write normal test to fix it and run again. What is important is that all tests are running in parallel, that you cannot be each call have to persist to another, not to persist to between calls. You cannot use global state or anything that depends on that. Why we won't use fuzzing? The main reason, as I already mentioned, are security. There is big Google project called OSS Fuzz that's not support just Go but other languages. You can see the C++, Rust, Go, Python, and Java, and any JVM. And for example, in January this year, OSS Fuzz already found 36,000 bugs in 550 open source projects. And that's quite important for global security using cloud native and other open sources. And another paper was around GFuzz, directly about Go open source. And there is a link inside this for paper if you want to read. It's about who goes first detecting concurrency bugs, and they found about 184 unknown concurrency bugs in Go open source software. That's very good for fuzzing too. And this paper is quite interesting. If you want to read, I recommend that. What type of bugs you can find it by fuzzing? That's exactly crashings, timeouts, race conditions, memory corruptions as overflows, leaks, some unhandled exceptions, undefined behavior. All of that you can find it. And if you look on that list, you can see that there are many of them are very common. Especially if you slightly looking into CVEs and security, almost 50% of bugs from security are this similar types. That's exactly why it's very good to use fuzzing for this. What should you fuzz? By literature, we recommend all inputs, yeah. But what is important and is usually test expose APIs, especially the public ones, all embedded software for consuming data about sensors, radios, other things. All cryptography should have this, and encryption software, and all databases, cryptocurrency nodes and similar software, IoT and medical and automotive, and industrial control systems, and parsers, marshals for text, video, and audio protocols too. That's not attacks only on text, but now quite often about video and audio formats too. And I will go through the fast tutorial. You can find him on GoDev site, and there is quite good tutorial. And we go together through the tutorial, and we find how that fuzzing is easy to use. We have these functions. It's called reverse. It's very simple. You just write string, you get reverse, and we reverse again, and we should get the output back. We run that function on my test sentence, and you can see that works quite okay. So some verb looks okay. And we write test for that, and it's simple unit test. You can see test reverse. We have some inputs, we have some test cases, hello world, empty string, some numbers. We run that test, and all nice and working, all is okay. We write fuzzing test for that. It's very similar. You can see that there are just a few differences that we implement that ffuzz function, and we reverse it and double reverse it, and we compare that, and if it's not valid UTF string, that we getting some error. We run it, and we have error. Why? That the previous test works, yeah, very good, no problems. Where is that problem? We get some invalid UTF-8 string. What should be problem? We look into documentation, and we find about valid string. This valid string reports whatever is consistently entirely valid of UTF-8 encoding runes. There is problem. Let's debug it, and we adding one line here for debug how many runes we getting on a reverse and double reverse, if will be that some issue there. That I run it, and you can see, we have one rune on input. After reverse, we get 2 runes. That's strange. And we get back, and we have 1. That doesn't work. Let's fix the code. That we change the byte here on input and change to run. And runs works okay. We run the test, all works, and we are okay with it. That we run that fuzzing again. Oh, another bug. And it's different, but we getting 1. That's another error. What can happen? We get this strange character that usually doesn't looks like UTF character. Okay, let's fix the code again. I will add into code this condition about just for valid strings on the beginning, and I run fuzzing again, and all the pass, all is fixed. That you see, that's very easy implementation. I think that many of us see on the beginning that I was completely wrong with that naive implementation. And now how we run it out in automatic way. We can run in CI. I make example running in GitHub Actions. You can see you just adding as another type of test, and you can limit the running of fuzz by fuzz time parameter. There are also fuzz minimalized time that you can run it to 0. It's unlimited time of running, and there is important by default is running in parallel using the $go_mac_procs, how many cores you have available. And that's important for a few reasons. That you have high CPU utilization on that fuzzing test, that you generate that corpus on the fly, and can be issue. And you have to be careful how long it takes. By default, without that fuzzing time parameter, it's run indefinitely, and that's not good for CI. I look on that limits for GitHub Actions. They already extended quite big. I think 6 hours now you can run it. You can see on link. That's much more generous than in times before, but still cannot cover everything. And not sure about your bill. But there is another CI tool called Fuzzbus. It's CI that are focused on fuzzing in general. They are in beta, and I tested that. And what is different on that is that you getting your VM that you can run unlimited time. It's usually you will pay maybe in future per how many VMs you have, but they don't give you any limitation about time. The UI looks in this way. You have some build regression testing. You have cover for some code coverage about fuzzing test. And if something doesn't work, you getting that line what doesn't work, what was that fuzzing data. This was some crash. And you have this nice way how reproduce on your local host. You just download the reproduce payload and use it on your local computer to fix it. It's very easy to use, but it's still in beta. They have a few issues to do it, but it's quite good to if someone interested in fuzzing, this is good to follow these guys. And they have very good blog about fuzzing in general. They write a few good posts. That's all from me. If you have questions, use Slido or ask here. I need one assistant for questions. And someone, Vilda, can you help me? If someone have questions here.
Well, actually, I have 2 questions. So the first question, so there is this notion of corpus and the way to generate the fuzzing data actually. So is there a way how to fine tune this process? I mean, like I've used several fuzzing frameworks already for different languages, and there's usually some nifty language invented just for its purpose, which allows you to let's say what should be the prefix, how to mutate it, what sort of bytes should be inserted, etc.
Yeah. We don't have exactly that, but you have 2 corpus. There are the seed corpus. They are directly in Go, and you have this generated. And the format of corpus is very easy, and you can generate the files very easily. There are a few open source tools that convert from other corpuses. There are for years available, and that OS Fuzz project, for example, you can generate, and there is, I think, something file to fuzz that convert the general format that are using for fuzzing, and you find many libraries on internet with corpus data. Yeah, and it's easy to generate by yourself too. It's just one line. There are a type, and second one is always the type and just that string in the type, if it's byte, string, or what you need for the testing.
Okay, thanks. The second question is, so what if you wanted to fuzz, for example, a state machine? So let's say you have an implementation of a protocol, let's say TLS, and you would like to fuzz based on state. So let's say you're in the middle of handling a message from the remote side, and the state machine reached some sort of state, and you would like to guide the fuzzing based on that state. Is there something in the framework that would allow you to do that? Because, you know, like fuzzing the whole thing would be too expensive computationally and otherwise.
I'm not sure. The fuzzing as is described this, and it's very minimal one in current implementation. But there are many of that other libraries that helping with complex structures, and it's just functions that you can easily, if you have good how you structure that code, you can testing the parts that depend on your implementation. But I think it should be possible that exactly it's focused, but this is implementation is very minimal, and there are many other projects that are focusing on that more complex things.
Okay, thanks. Yeah, I'm just asking because I know that Google folks are, you know, investing heavily in this area. So
yeah. This is from that part too. That I think that OSS Fuzz it's the main project running this across, and they just taking important part for Go, and there are still that official Go, and I think there are other implementation before was in Go, and there was big discussions what should be in that minimal, that special about corpus, what should be in language, what they make that small seed and generated, how big should be for corpus and other things. Discussions, and there are in Gopher Slack is very good kernel fuzzing. There are some discussions about that, and I think that's for future. And what is I think the best value from that is that it's simple to use. Yeah, that's there are existing before fuzzing, some of them, some for Go, but this is very easy to use, and that's quite important for starting and more people using that.
well, thanks.
Okay, thank you everyone, and see you in 5 minutes for last talk.